Yeah, yesterday I just stopped somewhere in the behind, and I never really thought I had to catch up something else, so I just started the streaming, but actually I had something to catch up. Unfortunately, so sorry about it. Um, I'm gonna resume from where I stopped. We had a basic exploratory analysis, made a few changes as well here in this part of this. And if you can see here, okay, that's uh that's unfortunate. Okay, so this is how we can get the image in PIO, and this is how we can get the image in OpenCV. OpenCV, the images is actually downloaded or actually loaded using PGR, whereas in PIO it is loaded in RGB. Most of the ImageNet libraries, computer vision models are trained on RGB frames, and that's one of the important things. I would start talking about it in future. And here is where I would load the train.csv file, and we can see the some of the samples from it, just data from it. So the tail contains all the targets with 0. And after that, I just used to plot the speed variable. Here's the speed variable here. Here's the speed variable, and try to understand how does it actually help us in predicting the crash and non-crash situation. Here the crash situations are in red and green, and the non-crashes in green. And you can see after 0.72 or something, all the points, all the situations will end up in crash situation. So that's a very good thing. But instead of that, I try to do what I would say is the differentiation. Yeah. Okay. Yeah. Here's the thing. I just did this. I don't know where the data is coming from. Okay. So sorry I didn't load that. I didn't load the trend.csv file. Within a few minutes, I'll get my data. I can just do the analysis, show you the analysis of how does the speed vary across videos. So video has 20 frames, so I just used the target after 20 frames here, and the accuracy, we just get the features, we get the speed feature, and we make it into number of n videos, comma that n frames is 20, so we will get this thing in that manner. This was the code I just did for normalizing video by video, but it didn't help. It wasn't easy to actually distinguish between them, but that's what we will be mostly needed in. We might be needed those features in real situation, because or else you have to uh, uh, our distribution might change maybe in the future. Don't know how does it going to be effective, but this is how. But the real important thing is that speed is not something we can have all the time. Not all the cases in the future. In production, we might have like even a future or speed feature or acceleration, but there will be cases. Maybe it's too much hard to actually get the images one. But here's the thing: images. If you can sort through images, it's going to be a very big need a very big effort, and it's going to be performing very well. there has been systems that actually incorporate the speed features, acceleration features, and predicting the crash and non-crash situations. But this is all about how do we um, use these features in our how do we use image visual features to actually understand if this is a crash or non-crash situation. Maybe maybe the speed isn't the only factor that actually contributes to the crash situation. Maybe it's a no light vision or no low light vision, all these things. So if camera could see through low light vision, I can understand what the environment is and can make the predictions so fast like that. That could be the that could be a very good prediction systems, I would feel like. But to start with, I always like to do some kind of exploratory analysis and make some kind of baseline model here so that we get an idea about how the baseline works and how should we improve the data. We take the rate of change of the speed. Although this is given as ACC accuracy, I just don't um, modified how the variable names are there given. I just take the absolute value so we can get every single thing on the upside of this value. And we can see that a lot of predictions on a lot of crash situations are about this line. I could consider this as 0.05, 0.06. Okay, so just did something like this one so you can understand what is the situation, what is the difference between them. Okay, I just did have that's not a very good part of it. Okay.